Hello, everyone. Good morning, good evening, good afternoon. Hope everyone's doing well in these challenging times. I'd like to introduce myself. My name is Mike Bonfilio, and I'm with a business called Bonfilio Consulting. I've got 40 total years in the business, 25 of which is in building automation and the Internet of Things, and 15 years in industrial automation. Today, as a consultant with Eagle Technologies, I want to cover a synopsis of how IoT, or Internet of Things, is impacting buildings and having a transformative effect on smart building automation and control. So we'll talk about how instruments will be used to gather the data, how the data can be used in a meaningful and constructive method. So it means more than efficient. It means more, as far as not getting bogged down within the sea of data that you have. How to convert a traditional building into a smart building, and hearing about smart buildings and how you apply building analytics. And then lastly, look at the technologies and tools available to get meaningful insight from all structured and unstructured data of a facility. So how the Internet of Things and smart buildings, what are the trends and challenges? So we'll get into some of those as far as market drivers and opportunities, complexity of buildings, and the building industry evolution. To start with, the Internet of Things, it does create opportunities, right? And if you look at the simplest definition of IoT, it's about allowing physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and actuators to communicate with each other over the internet in real time to enable these objects to collect and exchange data. And today we're seemingly able to control almost every aspect of our lives through smart devices we carry with us everywhere, such as smartphones, and then software applications that allow us to order transportation easily, access our home security cameras while on vacation, and even pay bills during our commute. The same expectations of simple management and improved personalization are moving to the workplace environment. So building efficiency features can lead to employee wellness and satisfaction through proper air circulation and temperature control, for example. With smart technology apps, a workplace environment co-managed by facility professionals and employees is possible. These apps can allow occupants to adjust building environment variables like heating, cooling, and lighting to create their own perfect work settings that meet their unique needs. These apps can also be configured to allow conference room booking, locate colleagues within the building, navigate to meeting rooms and other spaces. With these apps, employees are empowered to take control of their day-to-day workplace experience and increase their productivity. So as we said, data-driven technology trends and building operating costs will create these new business opportunities to solve your customer problems. There's a few standout reasons that add to the difficulty of maintaining a building. The average building goes through roughly 40 years without a major reconstruction or retrofit. In the typical building, you have more than 30 suppliers providing systems and equipment. Those products and systems communicate over many different protocols. Making sense of the data, diversity in building is complex. On top of that, you have regulatory environments, which require all this equipment and environments to be maintained slightly different. So how do we get started with smart building technology? A good deployment and setup strategy is the next key to launching a smart building technology initiative in your facility. Don't try to monitor every piece of equipment for every building system at first. That's an easy way to become overwhelmed. An initial IoT implementation could be as small as a wireless device added to an existing meter to collect data. And starting with just a couple of devices to keep your upfront costs low, a few sensors could run between a few $100s to a few thousand, depending on their complexity. And it makes it easier for facility staff to get the hang of interpreting and acting on the data before the system is expanded. So start with areas that will yield a payback almost immediately and use the savings to expand the IoT implementation. When you're ready to expand, determine what the logical next step is based on the data you're already collecting and what other information you need to gain the insights you want. There are also a lot of conversations around data right now. Its value continues to increase, whether as something that can be monetized for profit or savings, or in terms of improving understanding and operations for a business that uses it effectively. That's why the advent of artificial intelligence, or AI, and machine learning will allow us to quickly gain insights from vast quantities of data that was previously siloed. It has been such an incredible revolution. So you've converted your traditional building, you have the data, but now what? So let's look at these items on the slide here and go through each one of them. Let's start with big data and analytics. All these buildings that you have generate data. That raw data is aggregated into large data pools. But raw data by itself is useless. It's hard to drive value out of a bunch of random numbers. That's where analytics comes in. Regression, algorithms, rules, AI, machine learning, you've heard them all. We take all that raw data and run computations against it to pull out the value, looking for trends, anomalies, changes over time. The goal is to find meaning within the raw data. So on its own, big data, or any data for that matter, cannot solve any problems or do anything. It is only through the collection, integration, and use of the data in analysis that value can be provided, turning data into information and ultimately knowledge. Big data analytics can therefore be viewed as a tool that gives business value to large data sets. Essentially, it's about finding the gems in your sea of data. Companies today are awash with data. Gathering it all is the easy part. The hard part is sifting through it to arrive at meaningful insights that can help you make better predictions and more educated decisions. Now, one of the ways that you can absorb all this data is through a software as a service application, as opposed to something that might be on-premise. And where software as a service really pays off is when you have lots and lots of buildings in a big portfolio. So applications can be hosted on a service like Microsoft Azure or Amazon or Google, others. Customers can access those applications via the cloud over internet. So they can get into each and every building through that service. Generally, it's operations or OPEX focused as opposed to CapEx focused, which is a good thing we'll talk about later. And it's available as a subscription. So like an annual fee or a multi-year fee is also very beneficial. So you can spread those costs over many months, many years. So how does this help? Why would you do it? Well, it lowers that upfront and ongoing maintenance costs. You don't need these dedicated servers. You don't have to worry about that CapEx cost, because the servers are usually by the person that is running the service, the company that's running the service. You don't have to worry about installing software, especially when you have a multi-building portfolio. That can be a lot of cost. And the customer always ends up with the latest software version because it's on that server and it's loaded on that server when you have the latest release that is updated. And new features generally come with those new releases in near real time. So used across a portfolio, not just by building or location, is key to one of the benefits of software as a service. Now, what are the types of data analytics? Using data analytics to turn large volumes of complex data into actionable insights can help us improve engineering design and decision-making processes. However, developing effective analytics and integrating them into business systems can be very challenging. To move forward, it's important to identify the different types of data analytics. Let's start with descriptive analytics. It involves collecting data to help inform us about what has happened. The projection of descriptive analytics in buildings could include, for example, collecting sensors data that will tell us the fan speed has gone low, zone temperature has gone high, or overall power consumption has increased, etc. How about diagnostic analytics? These will inform us why a certain problem happened. For example, a fan speed change due to a building operation schedule change. And then there's predictive analytics. This is used to inform us about what will happen. For example, a predicted increase in the entire building's power consumption, i.e. a demand risk. Then there's prescriptive analytics. These further inform us about what should happen and are often involved in finding the best course of action for a given situation. Analytics removes many of the complexities that are built into buildings. A well-implemented analytics tool for buildings will continually monitor all aspects of the system in near time. The behavior of the mechanical systems, the control strategies, the effectiveness of any integration, the performance of the user-directed actions, the quality of the environment for occupants, and impact to critical business functions. The most important step when deciding to deploy a data analytics solution is to identify the process that will be used to act on the information. No matter how good the analytics solution, executing the findings is what really drives results. The future directions in building energy optimization is expected to utilize the latest in advancements in machine learning and optimization algorithms to model the underlying relation between the different sources of data and the building's power consumption to continuously evaluate building systems performance to detect and diagnose faults once captured. And there are much more in the way of use cases. So as you can see on the slide, there's companies using data and analytics software algorithms to further enhance their products and services, and also to integrate to other products and services from other manufacturers to provide a holistic solution. The main thing here is closing the loop, not just collect the data, not just have the insights, but to also do something with the insights. So many software apps in the market perform the data acquisition and generate the alarms and faults, but many do not go as far as making recommendations to address and close out the fault or issue. That's how we're going to get to the benefits of improved energy performance and reducing operation and maintenance costs and increasing equipment uptime and meeting regulatory requirements. This is how we drive visibility, accountability, performance, and maximum value. So the enterprise system becomes a critical factor in visualization of this data and insights. As we continue to consume more data and indulge in deeper insights, you need these powerful visualization tools, and they are evolving with Internet and Web 2 technologies. But they were constrained somewhat in meeting the dynamic and evolving needs of buildings, especially in handling unstructured data. So new visualization techniques evolving to meet the demands of big data analytics. Visualization is significantly unlocking the value of this data. So we are driving toward positive outcomes with the use of the enterprise systems that are coming out today or that are being enhanced over the time frame. So here's a couple of use cases that you'll find. One, which is generally in a BAS system, which is alarming. And the other one, which you'll find in an enterprise management system like fault detection and diagnostics. So these are two use cases, as we said, and typically alarms are identifying critical conditions. So they've met a limit, they've exceeded a limit, and they're immediately spitting out an alarm, and many of them, some cases where they're difficult, provides difficulty to the end user who's trying to sift through all the alarm data. Now, on the other hand, some of the enterprise management systems that feature very sophisticated fault detection and diagnostics are uncovering non-critical deficiencies. They bring in multiple points. They look at behaviors. They're looking at energy waste, suboptimal performance. So it's not just about a threshold or a limit. And so given the rules and comparisons and statistics and algorithms and AI, they identify different issues well in advance of an alarm. So this, in fact, could reduce a number of alarms and may be an early indicator of, as we say, a future alarm that might come out from a BAS system. But it's still beneficial to use both to achieve the best outcome. But using FDD will reduce those alarms, as we mentioned earlier, that could really overwhelm an end user. So how do we overcome the lack of integration between systems to support an IoT platform? There's multiple methods. These are probably not an exhaustive list, but some of the key ones that we see in the industry today. So we're seeing a number of companies build out a framework, as you see a framework here, and executing on that framework where they look at the data from the devices and integrate that into a data processing layer where they have a common data model and they have common services, data services. You can get these systems like actuators and devices, sensors, and so forth that have different data formats or from different manufacturers. So that data processing layer kind of normalizes it. It augments the data so that it's ready to work within the applications of a platform. So that feeds into the applications, that data normalization. You might have, 15 different security devices that have 15 different formats, but once it's normalized, they can work with that security application as an example. And then the information that comes from that security system, as an example, will feed into the analytics, through standardized dashboards, custom dashboards, KPIs, reports. So that's where the visualization comes in, that you can feed all these applications in, and they can work together or separately into an advanced analytics platform. So that's the framework that we're seeing today that really advances the information, the insights, the outcomes that we're looking for. Another method, excuse me, another method is establishing integrations by application programming interfaces. You may be familiar with APIs within a cell phone. You have a lot of apps on your cell phone that work together. That's generally through an API. The same is true in these systems that are in buildings. You could have a standard API that feeds the data in a one-way or two-way fashion to another application. So you could have enterprise management software working with a computerized maintenance management system as an example, or other third-party applications. And certainly another one is through BACnet, and there's many other systems, but these are some of the major manufacturers that are out there building automation systems that have BACnet capability. So that BACnet is a protocol that can be tied into enterprise management system very easily. So the building management system is what is it controls the operating parameters within the building, and then the enterprise system is looking at the big picture as we talked about before. So there might be, as a matter of fact, it could be multiple of these building automation systems in a, let's say, a school district or a college campus, as an example. Over the years, they put in different systems. BACnet helps you normalize that data coming into an enterprise management system. And then the enterprise management system becomes the primary reporting and decision support tool. It's a dashboard for data that can track trends and help decision makers. So I wanted to mention a study that's out there that might be of benefit to many people to take a look at. It's called the Internet of Things and Smart Commercial Buildings. It's a 2018 study, but it has a lot of good info in it. And it looks at an assessment of the market for the Internet of Things technologies, networks, and services in buildings. So IoT has had a transformative effect on smart building automation and control in recent years, disrupting long-established business models and offering significant new opportunities to improve the efficiency of buildings, raise employee productivity, as well as helping to stimulate the development of innovative new services. The report contains original analysis and forecasts, detailed analysis of the technology enablers, drivers, and barriers shaping the market, providing a comprehensive assessment of the competitive landscape and crucial insight into what is driving M&A and investments into the market. And they're talking about a 19 to 20% CAGR or growth rate in the IoT space for smart commercial buildings, probably higher. So what are some of the benefits of an IoT platform? We've talked about some of them already, but if you look at going from bottom to top or left to right, you know, the insights, we talked about it, right? So we want that real-time data, we want analytics, we want dashboards. That's going to increase the productivity within a building. It's going to work for facility managers and service providers and end users, right, to operate their buildings optimally and reduce downtime. That translates into improving comfort for occupants. And it empowers many times, some of the applications will empower the occupants to provide feedback and complaints via the app. It's a lot better to get that firsthand than to get complaints through another method, which might already be too late. That addresses some of the compliance requirements and provides also legislative reporting that is required. So some of the reports that come out of the system can be used as a compliance factor. And then the end result is obviously savings, right? We want to achieve a cost savings, and they're saying about 5 to 30% of energy used in commercial buildings is wasted due to faults and errors in the operations, right? Through the U.S. Department of Energy. So I would say if you're just beginning your program, you're probably going to see a much higher percent savings in that higher range. If you're well advanced, well, you may be looking at 5 to 10% a year, as you roll out or deploy newer IoT devices. So I want to thank you for your time today. Don't forget to let us know about your smart building projects or IoT projects, any maintenance management projects that you've got going, any building automation projects. Eagle Technology works with a lot of partners in this space through smart buildings, maintenance, and building automation. We'd like to hear from you. Tell us about your smart building or IoT journeys and how you can work with us and we can help you in that space. So once again, thanks for your time, and we look forward to hearing from you.